Right, I'm going to be doing the first 5 problems of the current voltage or current Ohm's law and series and parallel circuits worksheet. First, let's go over the equations. The first equation is going to be I equals Q over T, and that's current equals charge in coulombs divided by time in seconds. So the I is equal to current, and it's going to be measured in amps, which is abbreviated A. Next equation is V equals IR, also called Ohm's law, and so we're going to have V is equal to voltage measured in volts, and that's also known as potential difference. I is current, and R is resistance, and that's measured in ohms, and that's abbreviated with the Greek letter omega. Our last two equations we're going to have, I'm going to shrink this down, we're going to have our series and parallel circuit equations. In series, our resistors are going to add up by the equation RT equals R1 plus R2 plus R3 plus however many other resistors we have. In parallel, our equation is going to be 1 over the total resistance, and total resistance is also called equivalent resistance, equals 1 over R1 plus 1 over R2 plus 1 over R3 for however many resistors we have. Alright. We'll do problem number 1. Problem number 1 says, what amount of charge moves through an electric fan in 13.9 seconds if the current through the fan is 1.2 amps? So what we have here is we have our time is equal to 13.9 seconds. Our current is equal to 1.20 amps, and we are looking for the charge that flows through. So we're going to use I equals Q over T. I is 2 or 1.20 amps, and equals Q divided by our time, which is 13.9 seconds. We multiply our time by our current to get Q. We get Q equals 16.7 coulombs moves through the fan in 13.9 seconds. Right, on to problem. Problem 2 says, when a potential difference of 16 volts is placed across a resistor, the current in the resistor is 1.7 amps. What is the resistance of the resistor? So we have our potential difference or voltage is equal to 16 volts, and the current in the resistor is equal to 1.7 amps, and we're looking for our resistance. So we're just going to use the equation V equals IR, and our voltage, our potential difference is 16 volts, equals our current 1.7 amps, times our resistance, which we don't know. We need to find our resistance. We divide 16 by 1.7, and we get our resistance in that circuit is going to equal 9.4 ohms. Alright, so that's problem number 2. Going on to problem number 3. Problem number 3 says a current of 0.36 amps passes through a 1.7 ohm resistor. The resistor is connected in series with a 9.1 volt battery and an unknown resistor. What is the resistance value of the unknown resistor? Alright, so what we have here, we have I is 0.36 amps. We have potential difference or voltage is equal to 9.1 volts. And one of our resistors is equal to 1.7 ohms. We have another resistor, call that resistor 2, that we don't know the resistance of. So first thing we're going to need to do is find the total resistance in the circuit. And once we have the total resistance in the circuit, since they're in series, we're going to use the total resistance equals R1 plus R2 to find R2. So we'll start with using V equals IR. And R here is going to be our total resistance in the circuit, because we have the total current and the total voltage. So our voltage is 9.1 volts equals our current is 0.36 amps times our total resistance in the circuit. And when you do that math, we take 9.1 divided by 0.36. We get our total resistance to equal 25.3 ohms. So now, since they're in series, we're going to use the equation RT equals R1 plus R2. Right, series up here so we know. And so we plug our numbers in, we get 25.3 equals R1, which is 1.7 ohms, plus R2. When we solve that, we get R2 is equal to 23.6 ohms. So that's problem number 3. Problem number 4 has this diagram up here. And the first thing I'm going to do when I have one of these, if the resistors are not numbered, I'm going to number them. I'll number them in red. So this is going to be resistor 1, 2, 3, and 4. Alright, so this is a circuit that has a combination of series and parallel resistors. 2 and 3 are in series, and 2 and 3 are in series, and that whole thing is in parallel with number 4. And then 2, 3, and 4, that whole thing is in series with number 1. So we're going to kind of work from the inside out. So the first thing we solve for is the total resistance of resistors 2 and 3. And since they're in series, that just equals resistor 2 plus resistor 3, so 6.0 ohms plus 10.0 ohms equals 16.0 ohms. Next, so we have that top part. Now we're going to combine that top part with resistor 4, and those two are in parallel. So you're going to say 1 over resistors 2 through 4 equals 1 over that top part, which is resistance 2 and 3, so 1 over 16 ohms, plus 1 over resistor 4, which is 4 ohms, so 1 over 4 ohms. And when we do that math, we're going to get this equals 0.3125. And so we have R1, 1 over R2 through 4 equals that. So now we get R2 through 4 equals 1 divided by 0.3125. And when we do that math, we get that R2 through 4 equals 3.2 ohms. I'm going to shrink this down a little bit. So now all that's left is to include 1 in this now. So R1 through 4 is going to be equal to our total resistance in the circuit. That resistor 1 is in series with that whole thing of 2 through 4. So we're going to add resistor 1 to the resistance of 2 through 4. So we're going to say the resistance of resistor 1 is 2.0 ohms. We're going to add that to 2 through 4, which is 3.2 ohms. And then our total resistance in the circuit is 5.2 ohms. So that is problem number 4. Problem number 5. This one's a little more complicated. We're finding the total resistance and total current in the circuit. So we're going to do this the same way we did the last one. We're going to work from the inside out. So first thing we're going to do is find the total resistance of 3 and 4. Then we're going to find the total resistance of 6 and 7. Then we're going to find the total resistance of 2 through 4. Then we're going to find the total resistance of 2 through 7. Then we're going to add 1 to that, and that'll be our total resistance. Then we're going to use V equals IR to find our current in this circuit. So first thing, we're going to do R3 and 4 is going to be equal to, they're in parallel, so we're going to do 1 over R3 through 4. Let me start over here on that one. So 1 divided by R3 and 4 is equal to 1 divided by 15 ohms plus 1 divided by 21 ohms. And we do that math, we should end up with R3 through 4 equaling 8.75 ohms. Let's shrink that down there. So now we want to do R6 and 7 to combine those two in series. So we're going to say R6 and 7 equals 15 ohms plus 15 ohms. So that equals 30 ohms for R6 and 7. Alright, our next step is going to be to combine resistors 2, 3, and 4. We've already combined 3 and 4, and 3 and 4 are in series with 2. So we're going to say R2 through 4 is going to be equal to what we found for R3 and 4, so 8.75, plus the resistance of resistor 2, so plus 24 ohms, equals 32.75 ohms for the top part of that circuit. So R2 through 4 equals 32.75 ohms. There you go. So now we have to combine the top part of that branch with the bottom part. So 2 through 4 is going to be combined with 6 and 7. So we'll call that R2 through 7. And there's no 5 on here for some reason. And those are, erase that again, those are going to be in parallel. So we should be doing 1 over R2 through 7 equals 1 over R2 through 4, which is the top part of that branch, so 1 over 32.75, plus 1 over R6 and 7, which we found to be 30 ohms. And we do that math, we should get R2 through 7 is equal to 15.7 ohms. So now what we're going to do is we're going to do 1 and 2 through 7 are in series, so we're going to say R1 through 7 is the same as the total resistance of this circuit, since that includes all the resistors in the circuit. So our total resistance in this circuit is going to be equal to R1 plus R2 through 7. So R1 is 14 ohms, plus R2 through 7 is 15.7 ohms, and that ends up equaling 29.7 ohms. So that's the first part to find our total. Now we're going to use V equals IR with the R total to find I. So we do V equals IR, and we get 36 volts equals I times 29.7 ohms. And we do that math, we should get I equals 1.21 amps, and that's our final answer. So we found our total resistance and total current in the circuit.